Hello everyone again, Tom from EveryStepCalculus.com, EveryStepPhysics.com. I'm going to do another partial fraction one, a little bit more difficult. Each one is a little bit different that you need to learn about. So let's do it. Index 8 to get to my menu. I'm already at partial fractions, but you'd scroll to this because it starts at the top generally. Have to press alpha before you enter anything in here. So the problem is test problem also is x squared divided by the quantity x to the fourth minus 1. Close off the parentheses. I always show you what you've entered. Now, which one of you could factor this right here? That's the trick. I always show you so you can change it in case you made a wrong mistake in the first function. So here's the factor of it. And here's an x squared in one of the factors. What do you got to do there? This would be ax over x minus 1, b over x plus 1, and then you have an x squared. So you need to go cx plus d. Remember, every time you have a square inside the parentheses, you have to have a cx plus d. If this was located in the first one, you'd have ax plus b. If it was in the second one, you'd have bx plus c. But here's in the third one, so you got to have a and b already taken up, so cx plus d. It's one of the tricks. So here we have, you write this on your paper, x squared, which is the numerator, divided by the denominator. That's the original function. We multiply it. To get rid of this denominator, we multiply by the same denominator on both sides, except this side is factored. So we have a over x minus 1, b over x plus 1, and then cx plus d over x squared plus 1. Okay, that's the way you set it up. Now, since these are all pluses, you have to use common denominator to add fractions. And here's the common denominator right here. And so you do that, and here's what happens. You get ax plus 1 times x squared plus 1, bx minus 1, x squared plus 1, cx plus d. Notice the parentheses around cx plus d. Make sure you do that. It's a quantity. They're not individual. Times x minus 1 times x plus 1. Now at x equals 1, so we eliminate, remember these quotation marks here, the calculator does, but I want you to use parentheses. So you'd have parentheses around because you're switching 1 into every x in place of every x in this whole problem. And so here's parentheses here, you'd use parentheses right here. So 1 squared plus 1, etc. Remember to do that. And as you work each one of those problems out with the 1 substituted, they'll all come up to zeros except for the a. And that's the 4, so 1 divided by 4 is 1/4. So a is 1/4. Now we have a minus 1. You substitute minus 1 for every x in the, here's minus 1, here's parentheses here, minus 1 squared. Of course, it equals 1, etc. You do that through the whole system here, the whole partials that we just set up. And then these enter up to 4 except b. b is a minus 4, so we have b equals minus 1/4. Now generally we always try 0, x equals 0. We place 0 in every one of these. That means that the left side is going to be 0. Which it is here. Here's 0 and 1/4 plus 1/4, 0. So we get 1/2 plus a minus 1. We switch the 1/2 over to the other side, which becomes a minus 1/2. So d is equal to a positive 1/2. And here's the partial fractions here, exactly this. We integrate these now, and we have to use logs. which it does, log of absolute x minus 1 divided by 4 minus log of absolute x plus 1 over 4, and then tangent 1x divided by 2 plus c. That's the answer, integration by c. The calculator came up with this one here, tangent 1. I could do it step by step, but I figure if you do the whole problem step by step like we just did, and then you put this down, the teacher or somebody might not say, well, how'd you get that answer? This is the correct answer, and there's a way of doing it, but I just didn't show it in this because I wanted to be quick in doing the answers of the logs. Pretty neat, huh? Everystepcalculus.com